Very good morning, good afternoon, good evening to all my dear participants and students for this course. And the course title is Multi-Criteria Decision Making under the NPTEL MOOC series. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur in India. So, as you are aware that we are in the 35th lecture out of the total 60 lecture for this course, which means it is spread over 12 weeks. Each week we have 5 lectures and each lecture is for half an hour. So, the broader set of points we are or the ideas or the discussion we are going through and which we had for a long time are as follows. Multi-criteria decision making, we have discussed many relevant points. We are still in the domain of multi-objective decision making, trying to formulate different problems to understand how the maximization, minimization can be done for linear programming, integer programming or quadratic programming also. And then we did discuss the two very powerful tools in multi-criteria, where you give weights as lambda i's depending on the I as the number of objective function, or also we considered, as we were considering in the last day 34th lecture, we will continue doing so, is how to operate and try to optimize one objective function with the existing constraint plus the other objective functions being transferred into the constraints part. So, whether it is a maximization problem, minimization problem for any of the objective function, the idea remains the same. And obviously, the other points which we have discussed very briefly is the utility function. We will go into the multi attribute utility theory very briefly, but a little bit more theoretical, and then take the important points from multi attribute utility theory and try to understand the different concepts of other multi criteria decision making, which we had mentioned long time back when we were discussing the syllabus. Those techniques being Electra method, Topsis method, then the Vicor method and other things. The examples which we will consider in this 34th lecture is the continuation of the linear programming and the concept in MCDM, and the problems which are there for the linear programming can easily be converted into the integer programming. This should not be any problem, provided the objective function and the constraints are linear. Obviously, if there are non-linear also, we can consider that. The second coverage, hopefully we can start, or else it will be going into the next lecture, is the idea of NLP, where we will consider examples in the domain of multi-criteria decision making. So, the problem which we are considering, and I did mention quite a few times that this is a 3-dimensional problem x1, x2, x3. Why we are considering a 3-dimension? Because it will be easy for us to visualize. Even 2-dimension is also possible, and all of them are maximization f1, f2, f3, and I told time and again that f1 would be considered in red color, f2 in violet color, f3 in blue color, and the constraints are all the same for the case when we are trying to solve them individually. So, considering that we want to solve them individually, the constraints are given here. So, there are 1, 2, 3, 4, 5 constraints. The first objective function was denoted by f1 with the red color, f2 with the violet color, and f3 as the blue color. And we also considered that for single objective, f1 star would be the max value for f1, f2 star would be the max value for f2, and F3 star would be the max value for F3, and for all these single objective cases, when we get F1 star, F2 star, F3 star, the constraints are the same as shown here. These are the constraints. They will be applicable for case 1, case 2, case 3. Without going into much details, the first case, which is objective function 1 F1 maximization, the points are 20, 0, 0, F1 star is 40. We have discussed that. For the second case, F2 star being found out, the decision variables are 0, 20, 0, F2 star is 40. Third case, the decision variables or x values vectors are 0, 0, 20 and F3 star is 40. So, it is 20, 0, 0, 0, 20, 0, 0, 0, 20 and F1 star, F2 star, F3 star, all the values are 40 each. Now, we bring, as we are discussing, I am repeating the problem, but please bear with me. We want to maximize F1, this is F1, the constraints I will just put tick mark, these sets, these 4 here and the fifth one is here, and the two objective functions have been brought into the constraints. One is this, the one which I am marking in violet, which is related to the second objective function, and another is where I am putting the tick mark blue, which is the third objective function. They are less than, because we are maximizing. So, obviously, it cannot be more than a maximum value, it has to be less, and we will tackle the problem accordingly. The problem solution, depending which I told, delta 2, delta 3 are the values which are to be subtracted from F2 star and F3 star in order to have a feasible solution, and delta 2, delta 3 are given in column 1 where I put a violet tick mark, in column 2 where I put a blue tick mark. The corresponding x vector, which is x1, x2, x3 are given in the third column, and the corresponding values which we get for F1 double star is basically the other, F1 star was the max with a single objective. So, now with the two other objectives being in the constraint, how does F1 vary, that we are denoting by F1 double star. That is given in the last column where I put 2 tick marks, and the values are there. One interesting thing is that I have just noted down the values as they change. So, a darkish yellow, then the value of 39, there are 2 sets of 39 which I get depending on delta 2, delta 3. So, delta 2, delta 3, rather than that being important, what is important are what are the values of decision variables x1, x2, x3. They are same for 39, if you see, they are same 1910, 1910. Similarly, the green one is related to the objective function F1 star being 37.5, and the values are, I am not marking it here, but you can see is 17.5, 2.50. Then we consider 36.5 which is there, the values are 16.5, 3.50, and for a value of 35, when I have to talk about the value 35, this F1 star double star, the values of x1, x2, x3 are 15, 5, 0. Now, I go to the second objective function, which is F2 maximize, and all the constraints remain same, this 4 and this fifth one. So, 1, 2, 3, 4 and 5, and the two object function pushed into the constraints are corresponding to the blue one, which is objective function 2, and the red one is objective function 1. Again less than type, like f1 star minus delta 1 and f3 star minus delta 3. So, I again take different combinations of delta 3 delta 1, which are given in column 1, column 2, and the corresponding values of x 1, x 2, x 3 are given in column 3, and the corresponding values of f 2 double star is given in the last column, where I put a double tick mark black. Again the combinations of color like dark yellow, green, blue are done here in the same way, and only change which you see is the decision variables. So, for 39 it was, if you remember, when the 39 value was for f double star, f double star means f 1 double star here. So, the values were 1910. Here also you get 39 for f 2 double star, the values are 0191. So, the other combinations are just flipped and the values come out to be exactly the same. And again this delta 3 delta 1, which is there in the first column, second column, does not make much sense, only our concentration should be on the decision variables x 1, x 2, x 3. These are again replication of the same way for f 2 double star 35, the decision variables are 0, 15, 5. Now, we come to maximizing the third objective, which is f 3, subject to the same set of initial conditions, which are marked here as 1, 2, 3, 4 and 5, and the first objective there is there in the constraint, which I put a red tick mark, and second objective in the constraint, which I put a bullet tick mark, again violet tick mark, again they are of the less than type. So, I have to basically subtract a value of delta 1, delta 3 in order to obtain feasible solutions. The table which is shown here, we do exactly the same analysis. First column is related to delta 1 values, which are to be subtracted from f 1 star. Then the second column are the values of delta 2, which are to be subtracted from f 2 star. And the third column and fourth column, where I put a single tick mark and a double tick mark, are the corresponding values of x 1, x 2, x 3, the decision variables, which is in the third column, and the fourth column are the corresponding values of f 3 double star. And if you see f 1 double star, f 2 double star, f 3 double star, if the values come out to be same, the x vector, which is x 1, x 2, x 3, obviously changes. So, in the first case, when it is 39 for f 1 double star, it was 1910. Again going back 1910 here, I will highlight with, say for example, green color 1910 for 39. Then for 39, when I am interested for f 2 double star, it is 0191, where I am circling the decision variables, and 39 is also circled. So, this is the repetition for the other dark yellow, which I am not repeating. And for f 3 double star, again it is 1019, this 39 is f 3 double star, again a repetition here. So, the green, blue and the yellow, which you are seeing in the slide, had been already discussed, and in the same way we can obtain that. We have already obtained when we are trying to maximize objective function 1 with second and third objective in the constraint, then maximizing objective function 2 with first and third objective in the constraint, and this one which you are seeing is maximizing objective function 3 with objective function 1 and 2 in the constraint. So, these are the repetition. Now, I take all the values from these combinations and make a table, and I have marked it with different colors with a specific reason, and I will highlight that. First, concentrate on row 1 only. If you see row 1, it has x 1, x 2, x 3 given in red color and the corresponding f values f 1 double star, f 2, f 3 are given in the fourth column, where I put a double tick mark in red. So, the first column would go hand in hand in trying to analyze with the fourth column. If I consider, and obviously that becomes very obvious if you see the heading of the first column, which is x 1, x 2, x 3 is in red. Similarly, the heading which is in the fourth color, f 1 double star is in red, f 2 and f 3 are in their usual black font size or font color. If you see the second column and the fifth one, this one, the second column is corresponding to when I am only optimizing the second objective function, with the first and the third are in the constraints, that is why it is shown in violet, x 1, x 2, x 3 in violet, and the corresponding heading of the fifth column is given as f 1 is black font color, f 2 double star which is violet, and f 3 is black font color. Finally, so I am just mentioning what are the headings, then it will be easy for us to go through. Finally, you have the blue one, which is the third and the last column, and it basically corresponds to optimizing the third objective function with the first and the second in the constraints. So, that is why it is shown in blue. So, x 1, x 2, x 3 third column blue, and in the last column is f 1 black font color, f 2 black font color, and f 3 star is blue, as it should be. Now, let us see why did we make different coloring schemes for the values which are there in the table. Let us consider the part corresponding to the yellow one. So, if I consider the yellow one, the corresponding values of x 1, x 2, x 3 corresponding to f 1 being optimized in the objective function are 19, 1, 0, and the values for f 1, which is first objective being optimized, are 39, 18, 18. 18, 18 are the values for the constraints corresponding to the second and the third, which was basically 40, because it was delta 2, delta 3. So, the bit depending on the values of delta 2, delta 3, we obtained f 2 minus delta 2, f 3 minus delta 3, those values are 18, 18. Now, when we consider the values yellow in the second cell, it is 0, 19, 1, which is for second objective being optimized, first and third in the constraint, and the corresponding values of f 1, f 2 star, double star, and f 3 are 18, 39, 18. So, here it was done by f 1 minus delta 1 and f 3 minus delta 3. So, corresponding to delta 1 and delta 3 as 22, it was 40 minus 22, 40 minus 22 gave us the value of 18, 18 as you see. So, I am not writing deltas here, I am writing 40, 40 was basically the max value which we obtained for optimizing f 1, f 2, f 3 as single objective. So, we are writing that difference of f 1 minus delta, f 2 minus delta, f 3 minus delta, f 1, f 2, f 3 are basically the max values, f 1 star, f 2 star, f 3 star, as you want to say. Similarly, for the third cell, which is the heading is shown in blue for x 1, x 2, x 3, the values of decision variables are 1, 0 and 19, and the corresponding values of F1, F2, F3 star are 18, 18, F3 double star are 18, 18, 39. 39 is the value which you are getting, which you have already seen in the slides. If you go back to the slides, you will understand. And these 18, 18 are values of F1 star minus delta 1, F2 star minus delta 2. So, before moving on to the other colors like the dark yellow, green, pink, blue and subsequently. So, the values which you have seen in the yellow one and what I was talking about, this 18 being obtained from 40 minus 22, it will become clear here. If you consider the first one, it was basically for the, so consider here. So, this is basically 22 which is delta 2, and if I subtract 40 minus 22, this is 18. Here also 40 minus 22 is equal to 18, and the objective function f1 double star was 39. So, it was 39, 18, 18 which we saw, and the values of x1, x2, x3 which were red in color are 19, 0, 1, 0. Here it is 39, 18, 18, 19, 1, 0. So, this one. Right. Now, when I go to F2 double star, so again it is del 3 del 1 is 18 18. So, this is 40 minus 22 is 18. Here also is 40 minus 22 is 18, and this is 39. So, this was basically, oh, so I should basically use the, sorry my I should use the violet color, because we are following a coloring scheme which is much easier for us to discuss. So, if I, so this was 40 minus 22, 18, 40 minus 22, 18. So, the values of F1, F2 double star and F3 would be 18, 39, 18, and the values of x1, x2, x3 is 0, 19, 1. So, here you see 0, 19, 1 and 18, 39, 18, 0, 19, 1, 0, 19, 1 which you see, and 18, 39, 18. Finally, when we see this case or the values here, so for F3 double star, let us go back to F3 double star. So, I will remove this and go to, so this is equal to 40 minus 22 is equal to 18, again 42 minus 22 is equal to 18. So, this value is 39 and the values of x1, x2, x3 are 1, 0, 19. So, actually the value for the decision variables are 1, 0, 19 and F1, F2 and F3 double stars are 18, 18, 39. So, this is here 1, 0, 19 and 18, 18, 39. Now, with the same logic I repeat. Now, before I repeat, an interesting point to be noted. If I consider the sum of f1, f2, f3 as the overall objective function, then very interestingly you see the following. So, I will remove the colors not to make it too cluttered. Here it is. So, if I consider the objective function f1 double star, f2, f3, if I consider the total sum as a case of the multi objective, not singularly, as a case for multi objective. So, the value is 8 plus 18, 18, 36, 36 is 5 or 75, here also 75, here also 75, and all the objective functions are same, and these points which I am marking as in red as 1, violet as 1, why coloring scheme is the same thing to differentiate, blue as 1, then the red, violet, blue are the Pareto points with different points for the decision variable of the objective function if I consider as a sum of the objective functions of f1, f2, f3, with double star being for the first case, second case, third case, and the sum being 75 is the case or a nice way of trying to explain that for different Pareto points we get the same objective function. Now, if we repeat the same concepts considering the sum of the objectives f1, f2, f3 as the multi objective case, then let us see. For the case when you have the value of f1 double star or f2 double star or f3 double star as 38.5, then this dark yellow set of values would correspond to the case where you would have the Pareto points, this is number the one of them, second for them and third for them. And what is the objective function? Add them up. So, you will have it. So, here the objective function, if I denote it, would be 0.5 and this is 33, 71.5, 71.5, 71.5. Now, if I go to the two ones which are marked in light in the sea green or light green color, the last two one, others can be repeated for the pink one and the green one, we can repeat the same thing, but I am going to the last one. If you see the set of points, very interestingly 1550, which I will mark it as red one because we are trying to optimize f1, then the violet one and the blue one. So, I should mark it, sorry, I should mark it as and the corresponding values which I get is very interesting, even though that would not give the exact idea of Pareto optimal points, because the indifference concept do not cross each other. So, if I consider the sum for the second last column, so this would be is 8, 58, 58 for all, for of objective function which is sum of f1, f2, f3 which is 58, the Pareto points are given the last two columns as 1, 1, 1, which is 15, 0, 15, 5, 0, 0, 15, 5 and 5, 0, 15. But for the problems as we have considered, very interestingly, sum of the last values is given as 8 plus 3 and 4, 5, 53 here, 53 here, 53. So, value for 53 and 58 we get same sets of points. Theoretically, it may not be possible, because technically then in that case for the same set of points, if you are considering the utility, you are getting different values. We will take this problem later on. So, with this I will end this lecture and continue discussing more about it in the subsequent lectures. Thank you very much and have a nice day.